Okay, so we have this 2 times absolute value of x function, which is an even function, as you can see from the graph. And because of that, you can calculate a0 as 1 over 2 pi integral from negative pi to pi of 2 times absolute value of x. We use the doubling trick because integration from negative pi to pi is same as doubling this right side. So we put 2, and then we integrate from 0 to pi. And because from 0 to pi x is positive, you don't need the absolute value, which is a real time saver for us. These cancel, and integrating 2x gives you x squared. Then you plug in pi and 0, you just get pi as the result. Let's try an. An is 1 over 2 pi, not 1 over pi, integral from negative pi to pi of 2 absolute value of x times cosine nx dx. And again,
Both even.
yeah, they're both even, and even times even gives you even function. So we can use the same trick. 2 over pi integral from 0 to pi 2x cosine nx dx. And for this integral, we may use the tabular integration. Let me just write tabular here. So quick tabular integration, plus, minus. Or if you don't know tabular integration, you can just use integration by parts. So here's 2x, differentiating 2x gives you 2, differentiating 2 gives you 0. And you put the cosine nx over here, integrating cosine nx gives you 1 over n sine nx. Remember, anything that's multiplied to the x, you're going to see it as the reciprocal. And that happens every time you integrate, okay? You integrate this again, it's negative 1 over n squared. Negative because sine integrates to negative cosine, and 1 over n squared because another integration brings out 1 over n again. So you get this, plus, minus, plus, and then you extract the integral by doing this, straight across and diagonal down. And there's nothing here. Sometimes if this is not 0, you have to go this way and integrate the result. You don't need it. So the result is you get 2 over pi times 2x over n sine nx, and then minus times minus is positive 2 over n squared, so plus 2 over n squared cosine nx, and then you plug in
0 on the first one.
huh?
No.
Yeah, you plug in pi and 0, okay? And I also noted that there are 2 facts that get used a lot. Cosine n pi is equal to what?
-1.
Negative 1 to the nth power. And sine n pi is 0. Okay. And these facts are evident if you just draw the sine graphs and cosine graph. Okay? So when pi goes in here, you get sine n pi, which is 0. 0 goes in here, that also gives you 0. So this doesn't create anything at all. On the other hand, when pi goes in here, you get cosine n pi, which is negative 1 to the nth power, right? So you have 2 over pi, 2 over n squared, negative 1 to the nth power. And then when 0 goes in, what's cosine 0? 1. Okay. Or you can also plug in here 0, and that's negative 1 to 0 power, this 1, right? So when you plug in 0, that's cosine 0, which is 1, and you're subtracting that, so it's minus 2 over n squared. And since 2 over n squared is common, let's factor that out and multiply it to 2 over pi, which gives you 4 over n squared pi, negative 1 to the nth power minus 1. Okay. All right. What's the next thing? What do we do next?
Bn.
Yeah, Bn, right? Let's calculate Bn. Bn is 1 over pi integral from negative pi to pi of 2 absolute value of x times sine nx dx. Okay. And the answer for that integral is
Bn is 0.
0. Why?
Because it's a multiple of the even and odd function.
This is an even function, that's an odd function. If you multiply an even function with an odd function, you end up with an odd function, right? And odd function means one side goes up, the other side goes down. So if you integrate over symmetric domain, the two sides cancel. You get 0. So you just get 0. Okay, so we got a0 as pi, an as this thing, bn as 0. And the question was to find the Fourier series, and we haven't found a series yet. Series means you have to find the sum, infinite sum, right? Infinite addition. So the final answer should be written in that form. Okay? So let me write down the answer here. The 2 times absolute value of x, this function that's given to us will be equal to pi, we got a0 as pi, right? Plus summation of n equals to 1 through infinity of 4 over pi n squared, or n squared pi. I wrote n squared pi. Let me write n squared pi. Okay, and then negative 1 squared minus 1. Okay? No, why did I put that's squared? That's nth power, right? Oh, and then I have to write down cosine nx. Okay? And since Bn is 0, this doesn't show. And this really means it's equal. The two sides will evaluate the same value if you plug in any value of x that's between negative pi to pi. Yeah. So let's see, what's an interesting value here? Cosine. Yeah. So for example, here's an. So that's the answer. You can just stop it here. But let's think about an interesting fact that you can get out of this, which is let's see what happens if you plug in 0 both sides. So if you plug in 0 both sides, you get x equals to 0. You get 0 on the left side equals to pi, and then plus sigma n from 1 through infinity of 4 over n squared pi times negative 1 to the nth power minus 1. And cosine 0 is what? 1. So that doesn't appear. Okay. Let's move this to the left side. So you get 4 n squared pi. And because we're moving, these will both be negative. So let me write down 1 minus negative 1 to the nth power. And then summation n from 1 through infinity equal to pi. Okay. Now, what happens if n is even?
It's 0.
It's 0, right? If n is even, it's 0. If n is odd, what happens? You get negative 1 to the odd power, which is negative 1. So you end up with 1 plus 1, which is 2, right? So this actually says that for, so let's just say n equals to 2k minus 1. This is a way to represent all odd numbers because what's 2k? That's an even number, right? If you take any even number and subtract 1, what do you get? You get an odd number, right? So you can replace n by 2k minus 1, and this identity becomes summation of k from 1 through infinity. See, when k is 1, you get 1, k equals to 2, you get 3. So you're starting from 1, you get all the odd numbers. It's, this becomes 2, so 2 times 4 would be 8. 8 over 2k minus 1 squared over times pi equals to pi. Okay. Now you divide both sides by 8, multiply by pi, and this is the identity you get. You get that summation of k equals to 1 through infinity of 1 over 2k minus 1 squared is equal to pi squared over 8. Okay. Now what does that mean? We just show that 1 over 1 squared plus 1 over 3 squared plus 1 over 5 squared. If you take all the odd squares, 1 over odd squares, this value becomes pi squared over 8. It's kind of interesting, right? These are some summations where you could find the value only by these strange ways. So I might be going off a tangent here, but there's something called a zeta function, which is zeta of k is equal to summation of 1 over n to the kth power n from 1 through infinity. Okay. That's called Riemann zeta function. And zeta 2, which is 1 over 1 squared plus 1 over 3 squared, 2 squared, 1 over 3 squared. This value here. Does anyone know the value? I'm wondering if anyone knows this exact value of this sum. Oh, you don't see it in calculus ever because it's you can also get this from some I think you use X, or I'm not so sure which one, but it requires one of the Fourier series. Okay, so using the Fourier series and using an argument similar to this, you can get pi squared over 6. And then zeta 4, 1 over 1 squared plus 1 over 1 to the 4th, 1 over 2 to the 4th, or 3 to the 4th, and if you add this, you can also show that this gives you pi to the 4th power over 9. Now what's not known, and which could make you famous, is if you can figure out the exact value of zeta 3, which is this one, right? If you know the exact value of this, and if you can somehow prove it, then you can be famous. No one was able to figure this out so far. Kind of fascinating.